If engineers built a bridge as one solid, continuous piece of concrete, it would destroy itself before a single car ever drove across it. The sun would beat down on the deck. The material would heat up, and the entire structure would buckle and shatter. The problem is thermal expansion. When materials get hot, the molecules inside them start to move faster and push away from each other. This causes the material to physically grow. When the material cools down at night or in the winter, the molecules slow down and the material shrinks. This change is invisible to the naked eye if you are looking at a small object. But on a massive scale, it becomes a serious engineering hazard. A long steel bridge can literally grow by several inches on a hot summer day. If that bridge is bolted tightly to the rock on both sides with nowhere to grow, the expanding metal has to go somewhere. The pushing force creates massive internal compression. Eventually, the force becomes too great. The steel will violently bend out of shape. Engineers call this buckling. You can see this happen to train tracks during extreme heat waves. The solid steel rails grow, hit each other, and warp into zigzag shapes, throwing trains right off the tracks. So, engineers have to design structures that are allowed to move. They solve this problem using expansion joints. An expansion joint is an intentional gap left in a structure to give the materials room to breathe. Instead of pouring one long sidewalk, construction workers pour the concrete in small squares and cut deep lines between them. These are called control joints. Concrete shrinks as it dries, which naturally creates tension and causes cracking. A control joint tells the concrete exactly where to crack in a straight, hidden line, instead of breaking randomly across the surface. Bridges use a more complex version of an expansion joint. If you leave a simple open gap in a bridge, a car tire will drop into it and cause a massive bump. So engineers use interlocking steel teeth. These metal plates look like two combs sliding together. When the bridge heats up and expands, the teeth slide closer to each other. When it cools down and shrinks, the teeth pull apart. The gap is covered at all times, allowing traffic to drive over it smoothly while the bridge changes size underneath. You will find these gaps everywhere once you start looking. Stadiums are built in separate sections with rubber joints between them. Long brick walls have vertical strips of flexible cork every few dozen feet. Even the piping inside a large building has loops in it so the metal can stretch safely when hot water flows through. Structures cannot be perfectly rigid. If you try to fight the physics of heat and movement, the structure will lose. By leaving empty space, engineers allow buildings and bridges to bend and stretch without breaking. If you like knowing how the world around you is built, hit subscribe for more. That is how expansion joints hold up.